All right, students. I want us to take a look at this CSEC question. It reads, Figure 5 shows the schematic drawing of a 112 volts to 12 volts step-down power transformer with 2,400 turns in the primary winding, supplying 12 watts to a load resistor. A. Assuming that there are no losses in the transformer, calculate I. The number of turns in the secondary winding. So we're going to do that. We're going to calculate the number of turns in the secondary winding. But before we do that, let us see what information we have in the question. We know what the voltage in the primary and secondary is. We know the number of turns in the primary, and we know the power supplied to the circuit. Now, so VP is equal to 120 volts, VS is equal to 12 volts, power is equal to 12 watts, and NP is equal to 2,400. We are asked to find NS, the number of turns in the secondary. We're going to use this formula. VP over VS is equal to NP over NS. Let us plug in the values. What is VP? VP is 120 volts divided by 12 volts equals to NP, which is 2,400 turns, and divided by NS. So since NS is the one that we're trying to find, let's highlight it. Now we are going to cross multiply. 12 times 2,400, 28,800 equals to 120 times NS. The rules of mathematics still stands where it says if you want to remove the 120, you will divide by 120 and do the same thing to the next side. So that cancels that, leaving NS. That into that one time, that into that 240. So NS equals to 240 turns. Now we are going to take a look at B, finding the current flowing in the primary winding. Let's write down the information from the question. We know that voltage VP is equal to 120 volts. We know that VS is equal to 12 volts. We know that power is equal to 12 watts. And we know that number of turns in the primary is equal to 2,400 turns. We also know that the number of turns in the secondary is equal to 240 turns. Alright, there's a formula that I want you to bear in mind. And you'll see that all I did was add on current to the formula. So it's VP divided by IS is equal to NP divided by NS. And it's further equal to IS, and watch this now, the S for the secondary current goes on the top, and it's divided by IP. Now, to make a calculation, you will need either the NP over NS equals to IS over IP, or VP over VS equals to IS over IP. Now, we don't have IS and we don't have IP, so we have to find IS first, since the question is asking us to find IP, and we need one of these two combinations. We'll first have to find IS. Now, how are we going to find IS? Let's see. IS. We are going to use, let's highlight that, we are going to use a power triangle. I is equal to P divided by V. So IS, and since we're using IS, which means a secondary current, we will also have to use a secondary voltage. Now let's plug in the value. IS is equal to 12 watts divided by 12 volts, which is equal to 1 ampere. So we have found IS. Now that we have found IS, we can now use one of the two combinations. You can choose whichever. I'm going to choose VP over VS equals to IS over IP. What is VP? VP is 120 volts divided by 12 volts, and is equal to 1 ampere divided by IP. Now let's cross multiply. Twelve times 1 is 12. That's equal to 120 times IP is 120 IP. Now again, the rule of math, if you want to remove the 120, you divide by 120. Do the same thing to the next side. That cancels that, leaving IP, this into this one time, this into this, 0.1. So IP, or current in the primary, is equal to 0.1 amperes. What I want you to do is go ahead and try to use NP divided by NS equals to IS divided by IP. So use that combination and see if you get the same answer. You should.